Okay, so in this section, we're going to talk about separable equations. And the first part here wants us to know or wants us to determine whether the given differential equation is separable. So the first one we have here is dy dx minus sine of x plus y equals 0. All right, so again, we're trying to determine whether this is separable or not. So just to remind you that separable means that we can combine all the x's together and all the y's together. So if we were to add, move the sine x plus y to the right, so we add this to the right. Okay, so that gives us dy dx equals sine of x plus y. Again, excuse my handwriting. I'll try my best, but it's hard to write on this tablet. And then I would need to move the dx to the right side. So I have dy equals sine of x plus y times dx. Okay. But then I have to get this y to the left. Well, I can't do that because this inside the parentheses, x plus y, that's part of the function. Okay. Um, so I can't move it. So I'm stuck here. So in this case, the answer here is no. This is not a separable differential equation. Okay. All right. So this one we have s squared plus ds over dt equals s plus 1 over st. So again, we want to combine all the s's together and combine all the t's together. And if we subtract s squared, right? So s squared cancels there. We have ds over dt equals s plus 1 over s of t minus s squared. Okay, then I can try to get the dt over, mm, but then I still have the t here, right? So I can try to do ds s plus 1 over st minus s squared. Multiply that by dt. Uh, but then I still have the s's on this side. So again, this one I can't separate them as well, right? So this is not a separable differential equation. Okay, so in this case, we have ds over dt equals t times ln of s to the 2t plus 8t squared. And the key part here is remembering that the ln, when we have a power, we can move that based on the log rules. We can move that power, excuse me, in front of ln. So we have ds over dt equals t times 2t and then ln of s. Okay. And I'm just going to put that in absolute value because that has to be positive plus 8t squared. Okay. Then we can simplify this a little bit. And we have what? 2t squared ln of s plus 8t squared. And you can go in different directions with this. Um, what I did was I continue on and I notice I can factor out the t squared, but also there's a 2 I can factor out. So I have 2t squared and then ln of s plus 4. Okay, so if I multiply that back, I would get the 2t squared ln of s plus 2 times 4 is 8 and the t squared. So that is still good. All right. Then what we can do is we can multiply that dt to the right side. So let's see here. So we have ds and dt is equal to 2t squared ln of s plus 4. Okay, and then I'm going to multiply that dt to both sides. So that cancels there. So we have ds equals 2t squared ln of s plus 4 times dt. Okay, and then what we can do is we can divide, since we already have the t's here on the right side, we just need to move that s over. We can just divide this whole thing by ln of s plus 4 on both sides. Okay, so that cancels. And that leaves us with ds over ln of s plus 4 equals 2t squared dt. Okay, so so these first three here, so again, make sure you um, mark your answers there. But anyway, these first three, all they want us to do was try to separate them if we can. And then these next set of problems, we're going to solve them. So if we can separate them, great. And if we can, then let's try to solve it. All right. So again, the first thing we want to do is we want to combine all the x's and all the t's together. And then after that, we want to integrate. All right. So that's how we solve it. Okay, so I'm going to multiply dt on both sides here. So when we do that, we get dx equals 3x t squared times dt. Then I'm going to divide both sides by 3x. Okay. Then I'm going to separate this a little bit. So again, these are going to cancel. I'm going to break this down a little bit. So we have what? 1/3 1 over x dx equals t squared dt. Okay. All right. And then what we're going to do is we're going to integrate this on both sides. All right. So we're going to integrate this. So the 1/3 we can just leave out in the front. And then the 1 over x, that just becomes ln of x, right? So this is 1/3. And then the 1 over x, when you integrate that, that'll just become ln of x. Okay, and then we have a plus, and I'm going to call it C1. You know, I'm going to backtrack a little bit here, actually. No, that's fine. That's fine. Let's leave it like that. That's fine. Plus C1. Then this one would be on this side, I have t cubed over 3 plus C2. Okay. Okay, and then I'm going to combine the C's together. Okay, so I have 1/3 ln of x equals t cubed over 3. Then I subtract C1, so it gives me C2 minus C1. And remember, in separable differential equations, the C's just become a big C. Okay? So no matter what you do to it, it just becomes a big C. Okay? So, so in this case here, this just becomes a big C. Okay? So let me write this here. So we got 1/3 ln of x equals, it's like 5, but that should be a 3. And then we have t cubed over 3 plus a c. Okay? Then I'm going to move that 1/3 to the right, or in this case, I'm going to multiply both sides by 3. Okay, so again, I'm just going to take this, multiply the whole thing by 3. So then we're going to get ln of x equals 3 times t cubed over 3 plus 3c. Okay? The 3's are going to cancel, and we have ln of x equals t cubed plus, again, whatever we do to the c there, it just becomes, again, just a c. All right? Then what we do next is we want to get rid of the ln, so in order to do that, we are going to do base e on both sides. So we're going to do base e here and base e here. So then the ln and the e will cancel, leaving us with x. Okay, and then this here becomes, I can break this down into two parts, right? Because it's e raised to the t cubed plus 3. So I can break that down to e to the t cubed times e to the c. Okay? So remember these are the same, right? They're the same. All right, this is just another way to write that. And again, this e to the c will just become another c, big C. Okay? So so in this case, we'll have c times e to the t third, and then that will be our answer there. Okay, so again, we want to separate the y's and the x's. So when we do that, we get, so again, we have dy over dx equals x over y squared times 1 plus y squared times the square root of 1 plus x. So we're going to multiply both sides by dx. All right, so the dx cancels, giving us dy is equal to x times y squared, the square root of 1 plus x times dx. Then we're going to multiply both sides by y squared. Right? So that gives us y squared dy. And then the y squared will cancel, giving us x over the square root of 1 plus x dx. All right. So so in this case, the next part is we want to integrate this, right? So we integrate both sides. The left side is nice. That just becomes y to the third over 3 plus c1. The right side is a little bit more complicated. If we choose to do the top as our u is equal to x, then we just get 1 dx for our derivative, and that doesn't help us on the denominator. If we try 1 plus x as our u, then again we get 1. So again, sometimes it's kind of troubleshooting which is going to work. So again, if I try u is equal to x, my du here is going to be 1 dx, and that's not going to work, right? Because we have an x dx, I'm sorry, we have the square root on the bottom. If we try u is equal to 1 plus x, du is going to become 1 dx, right? And again, that doesn't work. If we try u is equal to the square root of 1 plus x, again, we're going to get something a lot more complicated, right? So it's not what we're going to have here. So, so which one is it going to work? Well, sometimes, remember from Calc 2, you can manipulate one of these. So let's focus on this one here, right? In particular, let's focus on the one here, okay? So if I have u is equal to 1 plus x, okay? What I can do is I can rearrange this and solve for x. So I'm going to move the 1 over to the left side, gives me u minus 1 is equal to x. Okay? All right? And my du, right? And du in this case will be, well, the derivative on both sides, the derivative of u minus 1 is just du, okay? Because the derivative of 1 will be 0, and then the derivative of x will be dx, or 1 dx, okay? So what I'm going to do here is I'm going to substitute this, all right? And hopefully it will help me. So my x now, okay, becomes u minus 1, all right? And then I have the square root of 1 plus x, so I can replace the x again, because I replaced this x by u minus 1. I can replace this other x by u minus 1. So I have 1 plus u minus 1, okay? And then dx here. All right, so if I keep going here, all right, I can simplify the denominator. So again, I have the integral of u minus 1, and then the ones here are going to cancel, leaving me with the square root of u. I'm sorry, this should have been du, not dx. Okay, I did it again. Du, there we go. Okay, so that's du. All right. Now, what I can do, because since this is just being divided by a single term, I can break this down to two separate ones, right, or two separate terms. So I can divide it, I can do or rewrite it as u over the square root of u minus 1 over the square root of u. Okay. And then we have du here. Okay. And then I can simplify this. This can become, remember, this is just u to the 1 here. If I bring that, the square root of u, the square root of u is just u to the 1/2. But since it's in the denominator, okay, it becomes u to the negative 1/2, right? So, so we'll have 1 minus 1/2, which is going to give me 1/2. So anyway, so this becomes u to the 1/2, and then this here will just be, again, I'll rewrite this as u to the negative 1/2 here. Okay, du. All right. Okay, and then now we can integrate. So in this case, we'll have u to the 3/2 over, and it's over 3/2, so I'm just going to rewrite that as 2/3 minus u to the 1/2, right? And then I'm going to rewrite that again as just 2 over 1 in the front. But again, there's a negative there. So it'll be 2 over 1. And then we have plus c. Okay. Let's see here. Okay. All right, so this is what we have on the right side. Again, this will be C2. Okay, so now what? So let me rewrite this. Let me write using a different color. Okay. So what I'm going to do is I'm going to take that C1 and bring it to the right. So we have y to the 3rd over 3, and it's equal to 2/3 u to the 3/2 minus 2 u to the 1/2 plus C2 minus C1. But again, just conserve on space here. I'm going to rewrite that as just a big C. Okay. All right. And then we're going to multiply everything by 3. So we get y cubed is equal to, again, if I distribute this 3 to each term, this is going to be 2u to the 3 halves minus 6u to the 1 half plus 3c, which again, this 3c, that again just becomes just regular c. We just rewrite that as a regular c. All right. And then we have the power of 3 here, so I can just take the cubic root on each side. Um, so the cubic root and the power there go away. And I'll write my answer right here. So we have y is equal to the cubic root of 2, and then I'm going to replace my u. So my u was 1 plus x, right? So I'm going to put those back. So 1 plus x raised to the 3 halves minus 6 times 1 plus x raised to the 1 half plus c. Okay, I just want to go back to this problem here that we were working on. Just want to explain this a little bit. I kind of rushed through this part of the problem, the integral of u over u square root of u minus 1 over the square root of u. So I pulled that out. And so again, just to rewrite this, we have u over u to the 1 half. And then I can rewrite that as u to the 1 times, if I bring that u to the 1 half up, that becomes negative 1 half minus 1, same thing here. I bring that, this here becomes 1 over u to the 1 half. Bring it up, that will give us negative 1 half. Okay. All right, so 1 minus a half is just a half, so that'd be u to the 1 half minus u to the negative 1 half. Okay, and then of course that's multiplied by du. So when we integrate this, this becomes u to the 1 half plus 2 over 2 divided by 1 half plus 2 over 2. And over here, this becomes negative 1 half plus 2 over 2 divided by negative 1 half plus 2 over 2. If we simplify this, again, this is plus c. If we simplify this, then we get u to the 1 half divided by let's see, yeah, 3 over 2, and then minus u to the 1 half over 1 half plus c. And then I can just flip this 3 over 2. It becomes 2/3 in the front, then u to the 1 half minus 2 over 1 to the front here of the second term, u to the 1 half. Sorry. May backtrack there. Okay, this should have been three halves in this one. Okay. All right. So that should have been 3 halves here. Okay. This is u to the 1 half. Let's see. Okay. So then after that, we just, as we did over here, um, um, put that back in, put whatever our u was. Yeah, u was 1 plus x. And so we just put the 1 plus x back in for u. But before we did that, we um, solved for y and then got y by itself and then put the the 1 plus x back into u. Anyway, I just wanted to expand this part here because I felt like I rushed that part, but this is how you break it down. Okay, so this next differential equation, we have dy over dx equals secant squared y over 1 plus x squared. So I actually really did work out this problem already, so let me just walk you through this. Okay, so the first step here on this left side of the screen, I separated the secant square y, so I moved that to the left and I moved the dx to the right. So right here, um, this right here, we got dy over secant square y equals dx over 1 plus x squared. Okay, now I can rewrite, so remember, I can rewrite the 1 over secant square y, and that can just become cosine square y. Okay, so that's one of the identities. Okay, so, well, technically it's 1 over secant y square, and then it becomes cosine y square. Okay, so anyway, 1 over secant y is the same thing as saying cosine y, but we have the square there, so we square both sides. Anyway, this is what we get here. All right, so we replace the 1 over secant square y with cosine square y dy. Okay, and then we have another identity here where cosine square y, um, we can rewrite that, and I have this over here. Cosine square theta is equal to 1/2 1 plus cosine 2 theta. So that's another trig identity. So that's what I ended up doing over here. I've just distributed that 1/2. So I had the 1/2 plus 1/2 cosine of 2 theta, or in this case, we have y. So we just use the 2y. Okay. So the cosine square y becomes 1/2 plus 1/2 cosine 2y. And then if you remember 1 over 1 plus x squared, um, the integral of that is going to be the inverse tangent or arctangent of x. Okay, right? So so that's how we got the 1 over 1 plus x squared being inverse tangent of x. Okay, that's the integral of that. Okay, now on this left side here, let's continue on. So we're going to break down the left side and integrate them into two terms. So we got the integral 1/2 dy plus the integral of 1/2 cosine 2y dy. Okay. We can move the constant to the front. So we have 1/2 the integral of dy plus 1/2 the integral of cosine 2y dy. Now remember, one thing we can do is we can replace 2y as u, so u equals 2y, then take a derivative. So we get du equals 2 dy, which is 1/2 du equals dy. So I'm going to replace this side here. So I have the 1/2 y. When I integrate this side, is going to be 1/2. The integral of 1/2, sorry, 1/2 integral dy is going to be 1/2 y. And then this part here becomes 1/2. And then I'll have the 1/2 because it's 1/2 du. So 1/2 du. And then the cosine, the 2y now becomes just u because I replace u equals 2y. Then we still got the inverse tangent x plus c on the right side. Okay. So when we integrate this cosine here, we get 1/2 times 1/2 will gives us 1/4, and the integral of cosine u will just be sine u, right? Because the derivative sine is just cosine. So we don't have to worry about a negative in the front of the sign there. Okay, then we have plus C1, then plus C2 on the right side. Well, we'll combine the C's together, we'll get a big fat C here on the right. And then our U, okay, we're going to put our substitution back in. So u was 2y, so we put 2y back in for u. Okay. Then we get 1/2 y plus 1/4 sine of 2y equals the inverse tangent of x plus c. Okay. And then we can do one more step here. And to kind of simplify this a little bit, we'll multiply everything by 4, right? And we'll distribute all this. Okay. So we get 2y plus sine of 2y equals 4 inverse tangent of x plus c. Okay. And this is the best we can do with this separable differential equation. We can't go any further. Sometimes, this is the best we can do. Okay. So this is going to be our answer here.